These are the doodle notes for Chapter 3, Section 4. So we're going to title this page. And the focus or the topics are on nonmetals and metalloids. So the first thing we're going to focus on is where are nonmetals located. And if you draw or redraw an outline of the periodic table and put in that zigzag line, you're going to find the nonmetals are on the right of the zigzag line. How do we classify nonmetals? When we talked about metals, we talked about shiny, how ductile they were, that they were malleable, that they were good conductors of electricity. Well, when we think about the classifications of nonmetals, it's exactly the opposite. So, they lack luster, which means they are dull. Remember, luster is how shiny something is. They are brittle, which means that they come apart really easily. They break apart. They're not very strong. So if I have a piece of coal, that coal will break into pieces very easily. And they are poor conductors of electricity. So if you jam them into a light socket, the electricity will not pass through them easily. So if I have a fire or electricity, that's a lightning bolt. They are bad conductors. So that's the top half of our page. Now for the bottom half of our page. When we talk about nonmetals making compounds, they do make compounds for the most part, except for the noble gases, and we'll talk about them in a minute. If nonmetals combine with other nonmetals, they will share valence electrons. But the noble gases are very stable and they will not share valence electrons. So now we're going to turn the page over and we're going to talk about really important nonmetals. One of them is, or two of them are actually comprise most of air. So in the top half of our page, we're going to make a pie chart. And this pie chart is going to represent air. And so about 80% of our air is a nonmetal. And this nonmetal is nitrogen. Okay, so what do we know about nitrogen? And I'm going to type this to make this all fit, but you can write it. So nitrogen is 80% of our air. We have to have it in our bodies, but we can't breathe it in. Our lungs don't have the capacity to do that, so we have to eat it in order to get it, because nitrogen helps our cells repair themselves and helps cells grow. So we're going to make this bigger so it all fits. Alright, so nitrogen is 80% of our air. We eat it and it repairs cells. Now, about 20%, not exactly 20%, because there's other things in our air like water vapor, carbon dioxide, argon gas, but about 20% is going to be oxygen. So that's the second most abundant gas in our air, and it happens to be a nonmetal. Oxygen is 20% of our air. It helps release energy. So we have to have oxygen to help our cells release energy. It's in our blood and our lungs. And it creates ozone in our atmosphere. And ozone's important because it helps protect us from UV rays. So those are the important things about oxygen. And again, this is a pie chart of our air. Now, something else we need to know is an important nonmetal is carbon. And carbon, this is a plant, is the element of life. So anything that is living or once was living is considered carbon-based. So carbon is the element of life, and we call things that have carbon, we call them organic. So if you're to ever study organic chemistry, you'll be studying chemistry associated with carbon or has carbon in it. Now on the bottom half of your page, that's the top half, we're going to leave a little space off to the side over here for our metalloids, which is not a nonmetal and it's not a metal. It's kind of a cross between the two of them. But I want to finish talking about our nonmetals. And group 17 are the halogens. And group 17 contains chlorine, fluorine. Now group 17, chlorine, is dangerous, but when it's combined with like sodium, it's a harmless table salt. So halogens can be very dangerous when uncombined. But when they're combined, they can be very helpful to us. And then we have our noble gases. That's group 18. And they are very stable because they have 8 valence electrons. And that's things like xenon, neon, krypton. And they have 8 valence electrons. Now that's it for our nonmetals. Now we're going to go to our metalloids. When we redraw our outline of our periodic table, you are going to find the metalloids on the zigzag line. Okay, so we've got nonmetals on this side to the right, we've got metals to the left, and on the zigzag line we have our metalloids. And they are sometimes metals, sometimes act like nonmetals. So what does that mean that they do? Well, sometimes they conduct electricity and sometimes they don't. And this is a good thing. So if you think about, I like to think of it like a computer, and they have silicon chips in them, which are metalloids. Well, sometimes you want the electricity to pass through the program and the program to work, and sometimes you don't. If you couldn't prevent it, all the programs would be running all at the same time, and that would be cumbersome and confusing. So when we don't want a program to run, we consider it cutting the electricity to it. So semiconductors are sometimes like metals and sometimes like nonmetals. And we're going to find metalloids in things like computers. And silicon is an example of that. And that's all for our doodle notes on chapter 3, section 4, metals and metalloids.